Mangoes are very delicious, right? And this fruit contains a saturated hydrocarbon, and we name that one as cyclohexane. So get ready to learn more about alkanes and how to name them. Get ready with your notebook, paper, pencil, study guide. Okay? So let us summarize the classification of alkane. Alkane can be classified into acyclic. Alkanes are also aliphatic hydrocarbons because it shows the properties of fats, right? So this can be classified into acyclic and cyclic. Cyclic means closed structure, and acyclic means not closed. We called it as open chain, remember? So it is not closed, not closed. So the not closed one, we have two types, straight chain and branched chain. Can have branches, right? Straight chain for the skeletal structure we can draw like that, for example, and for the branched we can draw like this, a branch here. All right, so let us go ahead and see some examples for the straight chain. Let us start with the one carbon. So we don't have a branched or cyclic for one, but remember we can name this one as with a prefix meth, ane as the suffix, so methane. And even for two carbon atom, we cannot have branch or cyclic, but let us just review the naming. So we have two carbons, so we have to have a prefix eth and ane as suffix. When we have three carbon, how is that going to look like? CH3, CH2, CH3. We can name the prefix is prop and the suffix is ane, propane. All right, so can I have a branch here? If you are thinking this way, say for example CH3, we can put a branch here with a CH2 here and CH3 here. This way, we never call that one as a branch. That means we are just bending the molecule. We can make it straight as well. So this is not a branch. Just like when a tree is growing like this, and it is due to wind, it is just bending like this. That is not a branch. Branch means it should come separate like that, or like this, right? That's how we can see it. And can we draw a cyclic for three carbon atom? So this one we cannot have. This is again still a straight chain. So now let me go ahead and show you the cyclic one. Two carbon, three carbon. So now we can join those and we will have 1, 2, 3 carbon. Okay, so how are we going to name this one? So we can name this one by putting the word cyclo in front of it and just write the name of the hydrocarbon, which is propane. Now let us try another example with the 4 carbon, CH3, CH2, CH2, CH3. So in this case, we know how to name it. But is the prefix, ane is the suffix, so butane. So in the branch chain, can we draw that? Let's try CH3 and we can put a CH here and a branch CH3 here. So I need total 4 carbon. So I have how many carbon atoms here? 1, 2, 3 and 4 carbon atoms. And hydrogen atom, we have 3, 6, 9 and 10. So we have C4, H10, that is still an alkane. But now you can see that the branch is formed here, right? So this is a different carbon atom attached to that one. And it is giving you a branch over there. Okay, so that's how we identify a branch. And now let us see the cyclic form of that one. How can we draw the cyclic form of that one? Is just like a square or rectangle. So you can see that each corner is carbon. So we will just add cyclo in front of it and we will just name it as butane, cyclobutane. All right, so now let us try another example, CH3, CH2, CH2, one more CH2 I am adding, and CH3. So we have now 5 carbon atoms. So the prefix is pent and the suffix is ane, pentane. Can I draw a branch for that? Actually, I can draw multiple branches here, but let me just show you one now. 1, 2, 3, 4, and 5. We have 5 of them now. And the naming of the branch chain we will learn separate. Okay, so that's better. And here we will draw a cyclic form of that. We have 1, 2, 3, 4, 5 carbon atoms. So we will just add cyclo and we will write what? The name of the alkane, which is pentane. And now one more 6. So CH3, CH2, 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 CH3. So let us see the numbering here. So I have 1, 2, 3, 4, 5, 6. So can I draw a branch? Definitely I can. I can actually have more than 1 or 2 branches, but I will just show you with a 1 again. And we will go ahead and try isomers. Remember, we were trying isomers before, and all those stuff we will do along with the naming, so we don't have to draw everything here just to show you a branch. Okay, so 1, 2, 3, 4, 5 and 6 carbon atoms here. So now we have a branch here. You can make branch on any other carbon except the end carbon. If you're making end carbon, that is just bending. It's not a branch. So how can we draw the cyclic form is we can draw 6 carbon atom, which is closed chain. So 1, 2, 3, 4, 5, 6. So we will just add cyclo and we will write hexane. To identify this one, you can see that all cyclic, we have cyclo in front of it. To identify this one, we will just write normal hexane too. Okay. All right. So let us go ahead and learn the naming in detail one by one. Just to give you some history of the naming was originally from, actually, they were taking the naming from, where is it actually originated from? For example, the formic acid they named because in Latin, formica means ant. So the acid present in ants, they called it as formic acid. Similar to that, the order of garlic is coming from Allium sativum, that is in the garlic. So that's a compound. So they named the compound allicin because it is originated from garlic. And now this name, I'm not sure, Barbara, maybe it is, that is what the textbook says. So it is coming from Barbara, the person who discovered it, something related to that. So it is called barbituric acid. Okay. So this is some interesting fact. So in the beginning, the names were coming from the object it is derived from or the person who discovered, but nowadays it is not by like that. There is a group of chemists. They formed a union and we call that one as international. It's not only from one continent. It is International Union of Pure and Applied Chemistry. That's a group of people. So they gave some rules. So now let me write that. International Union of Pure and Applied Chemistry. That's a union, and they are, as a group of chemists, they come up with the rules and how to name and how to uh, modify if it is required. Say, for example, the structure of butane. Let me write that. CH2 double bond CH, CH2, CH3. So we have 1, 2, 3, 4 carbons. So it was named as butene 1 or 1 butene. And then it is recently changed to the same compound CH2CH, CH2CH3. It is nowadays recent naming is but1ene because the double bond is on the first carbon. So some changes like that, not that big changes, but some changes whenever it is required, they decide on that. Another interesting fact about naming, you must have noticed on the over-the-counter medicines, right? You must have seen the naming like this to for example, this is ibuprofen. That is the more familiar name. We know that that is generic and trade name. They give just like a catchy names, easy to remember for customers. Whereas the real chemical name is, it's written there, 2,4,2 methyl propyl phenyl propanoic acid. It's not that easy for a customer to remember or to use it in everyday life. So they give the generic name and trade name, which is very easy for the customers to remember. But to name the larger alkanes, we have to follow this order: the prefix, and then parent name or the word root, and then suffix. Before, just we were having very small compound without branches and all, so we just prefixed with a number of carbon atoms. So that number of carbon atom is coming to the word root now, or the parent name. That determines the number of carbon atoms. Okay, and prefix means that will tell us if there is a substitute or a branch, and if it is cyclic compound, we have to add cyclo, so that will tell us the prefix. And then for suffix means it will tell us what type of bonding, carbon to carbon single bond, or carbon to carbon double bond, or carbon to carbon triple bond, or also it will tell us what type of functional group is there. Is it alcohol, is it acid, or is it aldehyde, is it ketone, etc. So we have to follow this order while naming according to IUPAC name, so that people anywhere in the world will not get confused which compound we are talking about, right? Because only one name for one compound according to IUPAC nomenclature. Let us have a closer look at the prefixes. They are the substituents. So the substituents are from alkyl groups. That means we are removing one hydrogen from the corresponding alkane. So alkyl groups are formed from alkanes. Alkanes, by removing one hydrogen, we are getting alkyl group. Okay, so we can see that Ne is removed by Yl. Examples: CH4 is changing to CH3, which is called, we know the first name is methane. Methane we will change to methyl. So methyl group is CH3. Okay. And now ethane, this is ethane. So ethane changes to one less hydrogen, that means CH3, CH2, or we can write two carbon together and hydrogen together. So we call it as ethyl group. This is our substituent, or we can say the prefix in our branched chain compounds. Okay. And now in this case, what we will do is name first. So this one, 3 carbons, so propane. So propane, we have we are going to remove one hydrogen, CH3, CH2, and CH2. Or we can write what? This disturbs me. Okay, or we can write, or C3, I have 3 plus 2, 5 plus 2, 7 hydrogen. So we will call it as propyl. Okay, and in this case we have 1, 2, 3, 4 carbons, so that is butane. So butane, I can remove one hydrogen, so CH3, CH2, 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 right? Or I can write I have 4 carbon and I have how many hydrogen? 5, 7, 9 hydrogen. So this is our butyl group. Okay, this is what we are going to deal with now. So is that the only substituents? No, these are only alkyl substituent. If there is Cl substituted in one of the hydrogen, we call it as chloro. If it is Br substituted, we call it as bromo. If something like that, right? So if there is any halogen substitute like that, we will just add O to that and then we will call like that the substituent. So we can explain that one while we go with the naming. Okay, so you should have a basic idea of alkyl group now. So we will explain the branch naming with these substituents. Let us try to name a branched chain compound now, alkane. So we don't have branches for CH4, we don't have branches for CH3, and we cannot have branches for CH3, CH2, CH3. So the first one will come for butane. Remember butane? Okay, so that is nothing but CH3, CH2, CH2, CH3. That is our butane, that is C4H10. Okay, so the first way we can write this one is C, 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 and C. So this is going to be the straight chain compound, which is going to be normal butane. Okay, but when you draw an isomer of that one with a branch, I can put a branch here. So now I have 1, 2, 3, 4 carbon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen. So how can we name this one? So now we know we have a branch here. That branch, what's the name of the branch? If it is all 4 hydrogen here for this carbon, we will call it as methane, but we are less 1 hydrogen. So we call that branch as methyl, right? And now what we will do is we will number the carbon atom in such a way that this branch will get the least number. So in this case, if we number from left to right or right to left, both are same. It does not matter here because in both ways we will get the number 2 for the carbon with the methyl branch. So now how are we going to name this one? That is what we have to think about. So the parent chain is here. The 1, 2, 3 carbon atom, right? So the order is first we have to put the prefix and then parent chain and then suffix. So prefix, parent chain and then suffix. So prefix is the substituent. The substituent is methyl. Which carbon is that one? 2. So 2 methyl and then parent chain is 3 carbon. So prop and suffix is this is a saturated compound alkane. So propane. Okay. So 2-methyl propane. Another name for this one is isobutane. Isobutane. Why is it like that? Because total number of carbon is 4. So there is a branch. So if it's only one branch, we call it as iso. Okay, so that's only possibility here. We cannot have 2 branches here. When I explain the 2 branches, I will explain the name for that one. So we can name either 2-methyl propane, that's the IUPAC name, and the common name is isobutane. So which one you have to write depends on the question it is asked. So you may see isobutane quite often because that's a normal name. And if I ask or if any test or anywhere, if it is asked you to write the IUPAC name. So that is 2-methyl propane. After learning all these substituents, let us start naming an alkane with a branched chain. So first step is to find the longest chain, that is the parent chain. So say for example, if we have an 8 carbon alkane with some branches, I'm going to draw like that. 2, 3, 4, 5, 6, 7. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8 carbon. Suppose I have branches here, here, and here. Okay, some branches. So then what I will do, I will draw another one with a 7 carbon here. Means the same molecule with a 1, 2, 3, 4, 5, 6. Okay, and then the branches are here, same molecule. So which one I have to look for the parent chain? That's what I'm trying to do here. So let us number it. So 1, 2, 3, 4, 5, 6, 7, 8. And if I'm numbering like this, 1, 2, 3, 4, 5, 6, 7. So which one is the longest? Is this one. So this is the correct one, and this is the wrong counting. So because it's only 7 carbon atoms here in the chain, whereas we got 8 carbon atom in the chain here. That's how we had to pick the longest chain. And now suppose if the molecule is like this. Let me show you this one. 2, 3, 4, 5, 6, 7, 8. And you have branch here, and branch here. Okay. And if the molecule is drawn like this, 2, 3, 4, 5, 6, 7, 8. And the branches are here, suppose. Okay. So this is 1, 2, 3, 4, 5, 6, 7, 8. That's okay, even if it is just bent. So, but still, that is the same. This is the same. Okay. So, it doesn't matter. It has to be in the straight line. It can be a little bend also, no problem. But you have to count without taking your pen. If you can count without taking, okay, let me draw one more, then I can show you. Let us start from here. 2, 3, 4, 5, 6, 7, 8. You see, I drew all 8 carbon without taking my pen from the screen. So that means it can be a parent longest or longest parent chain. Okay, it can be a parent chain, which is the longest one here. So that's a trick you can use without taking the pen. If you can draw it, that's the longest chain. Okay. And you should have the maximum number of carbon in it. I can draw the branches to make it same as the previous molecule. So this is same as this one is same as this one. All right. So that's how the first step we have to do. First we have to find the longest parent chain. Suppose you have a branch chain compound in which you can select the longest chain with the same number of carbon atom in 2 different ways. What we will do, let us see. In that case, what you have to do is select the one with the more substituent. So 2, 3, 4, 5, 6, 7. Okay. 2, 3, 4, 5, 6, 7. And now suppose I have a substituent here and I have a substituent here. And here I have a substituent here. Okay. So in that case, I can see that this one gives me the longest chain. And also this one gives me the longest chain. Okay. So what you will do, you have to go ahead and pick the one with the more substituent. That gives you more substituent. So this is the one you have to pick, not this one. So look at the branches. If you have more branches, pick the one with the more branches for the longest chain and select the longest chain. Okay. After selecting the longest chain, the second step is to number the carbon atoms. So how are you going to number the carbon atom? Is that select the lowest number for the first substituent. Say for example, let's say a compound 2, 3, 4, 5, 6, 7, 8 carbon atom, and I have a substituent, say for example on the second carbon, and on the fifth carbon I will put an ethyl substituent, and on the sixth carbon I'm going to put methyl substituent. Okay, so how can we number that? But that's what I'm trying to do. So I have substituent 1, 2, 3 here. So the first substituent should have the lowest number. So how do I know this is the first substituent, this is the first substituent, or this is the first substituent? So I know that if I number from this side 1, 2, 3, 4, 5, 6, 7, 8. I have the first substituent, this one. So that's the second one, right? If you're numbering from another side, 1, 2, 3, 4, 5, 6, 7, 8. In that case, the first substituent is on the third carbon. So which one I will select is the one with the second one. Okay. The scenario may arise if you have a compound with a substituent which is same distance from both ends. Say for example, let us say 2, 3, 4, 5, and 6. Okay, and let us put the branches here on the second one, third one, and fifth one. So let us number the carbon atom now and see. This is 1, this is 2, this is 3, 4, 5, and 6. All right, so the branches are on the second one now, and I have a branch on the third one, and I have a branch on the fifth one. What if I am numbering in the opposite direction, which is 1, 2, 3, 4, 5, 6. So I have branches now on the second one, and I have branch on the fourth one and the fifth one. So which one is the correct one? The correct one would be this one. The reason for that one is CH3 group is at a C3, which is the lower number. So second substituent on C2, which is lower number, then C4 in the second case, right? The second numbering. So we have to pick this one. Okay, so that's how you can actually do for if the substituents are the same distance, the first substituent same distance from both sides. Now suppose we have a compound with branches which are the same distance from both sides. And how can we number that? And both branches are different. Okay, two branches that result the same numbering from both ends. So look at this example: 2, 3, 4, 5, 6, and 7. And so I'm going to draw a branch here, ethyl branch, and I'm going to draw a methyl branch here. So when I number this one, 1, 2, 3, 4, 5, 6, 7, I'm getting ethyl group. This is going to be my ethyl group, right? Ethyl group at third carbon, and my methyl group is on the fifth carbon. And if I number on the opposite direction, so if it is 1, 2, 3, 4, 5, 6, 7, I am getting my ethyl group on which carbon? Fifth carbon, and my methyl group is on the third carbon. So what I have to do? Give the lowest number alphabetically to the first substituent. So which one I will pick? Is the green one or the red one? Ethyl at C3. That is ethyl comes first. E comes first, right? And then I will select C3 at C3. So the first one I will select, the red one I will select. So ethyl at third carbon and methyl at C5. That's the correct numbering for if you have branches that count same from both ends. We are into the last step. So what I will do, I am going to name the substituents now. Okay, so let us take the example, the previous example. 2, 3, 4, 5, 6, 7, and I have substituent on the second one, and I have a substituent on the fifth one. Okay, so I'm taking the substituent methyl. So I selected the longest chain. So the first step is the longest chain, that is called parent chain, and I will number them. Okay, number the carbon atom in the parent chain. Okay, and then I will name the substituent, and then I will combine all three. Okay, so because three parts there, right? So the prefix, that is our substituent, and then I will name the parent chain, and then I will put the suffix. So that means prepares, right? Prefix, parent chain, and suffix, prepares. So this one prepares us to write the name. So that is just my memory tip. Okay, so you don't have to worry about it. You can take this one if you want to. So I have the methyl group and I have the ethyl group here. And is it the same distance? So this one will be 1, 2, 3, 4, 5, 6, and 7. So I have a methyl group on the second carbon, so 2 methyl, and I have an ethyl group on the fifth carbon, so 5 ethyl, right? Okay, and then I have the parent chain, which 7 carbon means heptane, right? That's all I need. So prefix is the substituent. So substituent, I have 2 methyl, just picking a different color. I have 2 methyl, and I have 5 ethyl, and then parent chain is heptane. Suffix is, since it is alkane, heptane. Okay, so the last step is the alphabetic order. So I will just write 5 ethyl hyphen hyphen 2 methyl heptane. That's how we are going to write the name. Only 3 steps, but different scenarios may occur. That's the only thing we have to pay attention to. Let us try a few examples now. These examples, I will show you how to draw backwards. I mean, that is from the name to the drawing. So we have to identify from the name here, we have to identify the prefix, which is another name locant, and parent and the suffix. So in the first example here, 4 ethyl, 4 methyl. So I have two prefixes, 4 ethyl and 4 methyl. And the parent is hept. So hept, suffix is ane. And how am I going to draw? I should have hept 7 of them, 2, 3, 4, 5, 6, 7. And on the fourth one, 1, 2, 3, fourth one, I have to have an ethyl group and I have a methyl group. That's how you will be drawing. So for the next one is 3 ethyl as prefix, and I have hex. Hex is parent and ane is the suffix. So I should have hex means 6 of them, 2, 3, 4, 5, 6. On the third one, I have ethyl group. Next is 1-bromo. So 1-bromo is our prefix. I have pent and I have ane. So pent means 5, 2, 3, 4, 5. And on the first one, I have bromine. This is the first carbon and bromine is attached to it. Next one is 4-methyl. And hept is the parent. An is the suffix. So let us try. So hept means 7, 2, 3, 4, 5, 6, 7. On the fourth one, 1, 2, 3, fourth one, I have a methyl group. All right, so that is one practice. What you can do in the study guide without looking the answers here, try and come back and check your answers. Let's try this example. So for writing this one, I need expanded form. So there are 3 CH3 group on one of the carbon. So I'm going to expand it. All these 3 are CH3, CH3, CH3. And that is connected to a CH2 group. And then a CH. And then it is CH2, CH3. I have 2 of them. So on the same carbon, CH2, CH3. That's expanded form, which is going to be easy for us to name. So now what I will do, I have to select the first step is to say the longest carbon chain. So it looks like this is the longest carbon chain, right? Because I can see the numbering 1, 2, 3, 4, 5, 6. I can get 5, 6 here too. So in both cases, let us see what's the difference. If I go with a straight chain, I will have the substituent on the second carbon atom. There are 2 substituents. And I have on the fourth carbon, there is a substituent. And if I am numbering from right to left, I will have third carbon atom substituent, which I don't want. Okay, that's the reason I'm going to stick with this one. And I can see that one. So now the third numbering is done. I pick the parent chain, longest chain, and now I have to name the substituent. I have a substituent which is called methyl here, and this is also methyl here, and this is ethyl. So I named the substituent. Now I am ready to name this compound. So how am I going to name this compound? I have now ethyl group and methyl group. So E comes first and then M. So first I have to write 5 hyphen ethyl hyphen. I have 2 substituents on the same carbon. So 2 comma 2. They are the same substituent. So I just have to write di instead of repeating the same substituent name. So 2 dimethyl and the how many carbon atoms? 6. So hexane. Hex, and since it is saturated, ANE ending. So that's the name going to be 5-ethyl 2 hyphen dimethyl hexane. That's the name for this compound. This example also I need to expand this one in order to make it more clear. So CH3 is attached to 3 other CH2 groups. So straight CH2, CH2 and CH2. How do you know it is going to be straight? It's not branch because it's already 3 carbon atom attached to it. So only way to attach the rest of the carbon is the straight. So that's a way we can identify. And then I have a CH here. So CH and then one hydrogen and another carbon. So 2 bonds satisfied for this carbon. So then it says CH2, CH2, CH2 together attached. So that means it's going to be CH2, CH2, CH3. Okay. And then I have another CH here. That means I have only 3 bonds here. What is that here means is, so for this carbon I have only 3 bonds. So 1 to the hydrogen, 1 to this carbon it is attached, this bond and this bond. So 3 only. So that means this CH is attached to this carbon. This CH is attached to this carbon. So that will be CH here. And to that CH I have 2 CH3 group attached. So what I will do, 2 group attached here, CH3 and CH3. So this carbon atom also has 4 things around it, 4 bonds, one for hydrogen, one with this CH, that is this carbon, and then another one with a C, another one with a C. So all satisfied here too. That's how we will decide how to expand. So you may want to practice that as well. Without looking this one, try to write and come back and check the answer again. Okay, so I have all this, and now the second step is parent. Select the first or the longest parent chain, right? So 1, 2, 3, 4, 5, 6, 7, 8. That's the longest, definitely, by looking at it. No need to recount or anything. So it is very clear that that's going to be the longest chain. And if the substituent is now on the fifth carbon, what if I number from right to left, which is going to be 1, 2, 3, and the substituent is going to be the fourth one. So that is the right number. 5, 6, 7, 8. So that's the right numbering from left to right. And now I'm ready to name the substituent. So the substituent is here. How can I name? So how many carbon atoms are there? So that's what we have to look now, right? So the carbon atoms here, I have 1, 2, and 3. So definitely that is propyl. So we have two propyls. What are the two propyl substituent? Normal propyl and isopropyl. It is not normal because the hydrogen is removed from the secondary carbon here, right? So since hydrogen is removed from the secondary carbon, we have isopropyl. So we will just write this is isopropyl as substituent. So now I'm ready to combine the name. So first I have to have prefix, and then I will write the parent and then suffix prepares you. So prefix is the substituent. So on which carbon atom is this one? Fourth carbon atom. 4 hyphen isopropyl and then hyphen. And I have, is there any other substituent I have? No, so I don't have to have a hyphen here. So I don't have any other substituent. So what I will do is 4 isopropyl and I have 8 carbon atoms. So that means the parent oct, and then I have ane as suffix. So we have 4 isopropyl octane. That's a name for this compound. Let's see one more example. If it is an alkene with a double bond like this, no big difference. Only difference is you will end the name with a ene and you will number the carbon atom in such a way that the double bonded carbon will have the least number. What does that mean? Let us see. So the name should end in ene because I already see a double bond here. And now I have to number the carbon atoms in such a way that the double bonded carbon here should have the least number. So 1, 2, 3, 4, and 5. If we are numbering from right to left, it will look like 1, 2, 3, 4, and 5. Look at the numbers here. So 2 is the least, not 4. So I will go with this from left to right in the numbering. So how can I name it is the same method. So there are 5 carbons, so I have to start with the prefix pent and the double bond present. So the name should end in ene, pentene. Okay, so that's the only difference for the double bonded carbon. To see these examples, how to name them and how to identify whether it is an alkane, alkene, or alkyne. C2H4. C2H4 means 2 times 2 is 4, and I'm not adding or subtracting, so that is an alkene. So the name should end in ene. There are 2 carbon atoms, so the prefix is eth, and the name should end in ethane. So how can I draw this Lewis dot? Is carbon to carbon double bond and satisfy the other bond by hydrogen. So you can see that C2H4, right? So that means CH2, CH2, all right? And C3H6, 3 times 2 is 6. So that again, ene ending because that's an alkene. So that is prop is the prefix, and so the ending or suffix is ene, propene. So that means I have 3 carbon atom. It did not mention on which carbon, so I'm going to put it here. So 1, 2, 3, 4, 5, 6 hydrogen. So CH3, C, H, CH2. Okay, so then now say 4H8, 4 times 2 is 8. So that will be again alkene. So but, prefix and suffix is ene, butene. So 1, 2, 3, and 4. So I'm going to put one double bond here. How do we know only one double bond or two double bond, right? So here C4H8. So the number is actually just for one double bond because 4 times 2 is 8. So now let us see by putting one double bond, how many hydrogen here now? 2 and one hydrogen here. So 1, 2, 3, 4 bonds around that carbon. So 2 plus 1, 3 hydrogen, 4 hydrogen, 5 hydrogen, 6, 7, and 8. So only one double bond. So you can see that one by drawing the Lewis dot as well as by looking at the formula. So this is our butene. And now if there are 5, pent is the prefix, and 5 times 2 is 10, so that ending should be ene. Why is it coming like that? I have no idea. Okay, so that is pentene. Okay, so C. First I will draw that, and I will put a double bond anywhere you want, and then 1, 2, 3, 4, and then here 3 already, so one more, 3 already, one more, 2 only, so one up and down, and you can see that we have 3, 4, 5, 6, 7, 8, 9, 10 hydrogen. Okay, so that's how we are going back, writing the name and the formula. If it is triple bonded alkyne, let's see how to do that. The same usual method, only difference is what? It's going to be YNE ending because it is an alkyne. I can see a triple bond and the number should be the least number for the triple bonded carbon. So it should go like this. So there are 5 carbon. So I have to have the prefix pent and it should end in YNE, pentyne. That's the only difference for triple bonded carbon atoms. Now let us do these examples. So we can see C2H2. C2H2 is, so with the formula we can try 2 times 2 is 4. So it is not ENE, and 4 minus 2 is 2. So it agrees with the formula CnH2n minus 2. So it is alkyne. So the suffix is supposed to be YNE. So there are 2 carbon atoms. So 2 carbon atom means the prefix is supposed to be eth. So eth and the suffix is supposed to be ENE. How can we draw? So we know that is a triple bond. YNE means alkyne triple bond. So C triple bond C and the other fourth valency is satisfied by hydrogen. And C3H4 again C3. So 2 times 3 is 6. 6 minus 2 is 4 again. So this is alkyne. So 3 means prop is the prefix and YNE is the suffix. So we can draw C, one hydrogen here, 1, 2, 3 hydrogen on this carbon. So this is our Lewis dot structure and the condensed structural formula will be CH3, C and CH. Correct? Okay, and now how can we draw the skeletal formula? So here we have triple bond. That means here one carbon and here another carbon, here another carbon. So for the triple bond, you have to be careful like that because it is sp hybridized. And now for the fourth one, it will be but, and we can see from the formula it is the suffix is going to be YNE because it's alkyne. And so there are 4 carbon atoms, 1, 2, 3, and 4, and I'm putting the triple bond 1, 2, 3, 4, 5, 6 hydrogen. How can I draw the, or how can I write the condensed structural formula? CH3, I have CH2, and one carbon here with a CH here. How am I going to draw? The skeletal formula is first carbon, second carbon, third carbon, and fourth carbon. So third carbon and fourth carbon here, triple bond. So one here, two here, third carbon here, and fourth carbon here. Two is here. Okay, so now this one is going to be C5H8. So that means pent is the prefix, and we can see from the formula that is an alkyne. So YNE is going to be the suffix. So 1, 2, 3, 4, and 5. So let me put the triple bond somewhere else so that you can see the difference. Let me put here. So here 1, 2, 3, and here 4, 5, 6, 7, 8. These two carbon atoms here, second and third carbon atom is already having 4 bonds around it. So what is going to be the condensed formula? I have CH3, I have carbon and another carbon, and CH2 and CH3. How can I draw? The structure skeletal formula is the first carbon is here, and that is bonded to a triple bonded carbon. That's the second carbon. And I have the third carbon and the fourth carbon. So this is going to be the third one. This is going to be the fourth one. I have the fifth carbon here. So where is the triple bond? Triple bond is in between second and third. So this is sp hybridized and this is sp hybridized. So it's going to be linear. So that's the reason we have to draw pentine like this. So just practice, and this is a good review from chapter 1.